Hello and welcome to my tutorial on how to use color transformation with the help of AI for AMVs. I used it a lot for my last collaboration video on Eureka Dreamscapes. You can check it out on Arcothy or on my channel. Feel free to leave a like or a comment. We appreciate it a lot. So these are the points that I will go through in this tutorial. Timestamps are in the description of the video. Just click on them to get on the specific parts. I will not go over the installation of Stable Diffusion and Automatic1111, but I will provide you a link to a tutorial on that in the comments. Also would like to point out that this is my way of doing things. Many steps I will tell you might be outdated or not correct. However, it will be enough to point you into the right direction. Also, this tutorial does not claim to be complete in any way. With that said, let's move on. So here is why you want to use color transformation. With the help of AI, you can transform color from one image to another. You get pleasing, interesting results much faster, and they are mixed into your images in a way more natural way. Usually, when I try to overlay this image onto this video, there would be a lot of trial and error, with blending modes and so on. It would take me, well, a lot of time to make this look right. I'm well aware that this might be a skill issue on my side. However, the clear benefits of color transformation will be obvious the further on we go in this tutorial. I really like the topic and it's interesting to me because this is based on the AI Stable Diffusion, and I just love to play around with these all new tools and see how I can use it in my projects. I'm pretty sure that this will be part in future projects and that it's well, way more than just another AI tech gimmick. It's actually quite helpful to me. Here are the requirements. These are based on my estimates and personal experience. I think a mid-range PC will do. Mine is built in 2018 with some mediocre Ryzen CPU, but what's more important is the dedicated graphics card. I use an Nvidia 1080 Ti with 11 GB of VRAM. That was enough for 1080p images, but I think it was at its limits, to be honest. If you have a lower level card that can't handle 1080p images, you might want to create 720p images and upscale them later in an image upscale like Topaz AI, 552X or Cupscale. I suggest the free 552X. And for people who are more tech savvy, you might want to have a look into Cupscale, since this program gives you a lot of options and cool upscaling models, and models for cleaning your footage. Furthermore, you need to install Stable Diffusion. In this tutorial, we will use the easy interface Automatic1111. You can find links to an easy, fast installation guide and tutorial in the comments of this video. So, you get Controlnet by keeping Automatic1111 up to date. For this, you start your Stable Diffusion, go to the web interface in your browser, then you go to extensions. First you check for updates, then you apply and restart, and to install Controlnet itself, you go to install from URL, paste this link into URL for extensions Git repository, then you press install. And it might be a good idea after the installation is complete to go back to installed and press apply and restart UI. The models that I used are the Stable Diffusion model, anything version 4.5. You find it on huggingface.com. It is an AI model tuned for anime, but I think the standard Stable Diffusion models will do as well. Next, you will need the according Controlnet adapter models, which will work with its according Controlnet preprocessors. Well, this sounds complicated now, but we will get to this later. I use the T2i adapters for my color AMV on the Eureka Dreamscapes. You better download them from Hugging Face. Links are in the comments again. Go to your Stable Diffusion web UI root folder, then go to extensions, SD web UI, Controlnet, models, and download them right into this folder. Last but not least, you will need to know how to work with image sequences and how to export them from your video editing software. And you will need some nice vivid color assets to play around. I got mine from Pinterest. Those don't need to have a high resolution at all. Alright, let me show you the fast way how to do things. We will later on go into all the details so you can make better adjustments, but just for now, the quick solution. First off, start your Stable Diffusion web UI. This might take some time. You can always choose the console and see the status of Stable Diffusion. This might become handy if you need to know if anything of the processes got stuck or if you ran out of VRAM. The console will tell you anything you need to know in terms of errors. Well, they can be quite obscure and cryptic, but at least you know when something's stuck or if there's a critical error. Alright, when Stable Diffusion is all fired up, open it in your browser. This is the interface of the GUI Automatic1111. So, go to image to image, upload your image you want to alter, then set the desired resolution. In my case it was 1920 by 810. If you're working 16 by 9, you might enter 1080p. CFG scale gets turned down, denoising gets turned down to 0. I set the C to a random number, but don't keep it at a random number every generation, so I type in something else. So then next step, we fire up Controlnet. Controlnet should be listed here, right under the seed. First we need to enable Controlnet. I think it's not a bad idea to always turn on low VRAM. At least it helped me for my works. Then I upload the reference frame. There it is. Then I go to preprocessor and take tile color fix. And as model I take T2i adapter color. Then with this little explosion emoji you can test it. And if you get out a proper image on the right, everything works. So then we leave control weight and variation at the default numbers, keep everything at default, then we scroll up, press generate. Then we can open up the console and see how it's doing. Alright, and here I have it. My generated image with some beautiful vivid colors. And I get the reference frame, what I think Controlnet laid over it. Alright, that was the fast and easy mode. Let's go into details of things. First off, you might have noticed that I don't have a Stable Diffusion standard model selected, but anything 4.5 is a model based on Stable Diffusion 1.4, and it is specialized and trained on NI material, so this might help. But to be honest, I think it doesn't really matter which model you use for Controlnet Colour Transformation. So we go to image, then here we upload our image. Here we can choose the sampler method. Honestly, I don't know if a different sampler makes different outcomes, but I sometimes have strange AI artifacts in bright areas. Maybe switching up the sampler method will help. Sampling steps, I think we are alright at 20. If you want to make sure and get better details, maybe try editing the sample steps to a higher value, but for now I don't think it matters too much. So if you enter 1920 by 810, what I used for this project, you will not get the same resolution out of your images. I think it has to do with the inner workings of Stable Diffusion and the final results of images that I got out with my desired resolutions were actually 1920 to 808. So I had to rescale the images in my editing program, and this might stir up some problems. So keep in mind that your desired resolution might differ at the end. If you use a height of 1080, you will be alright and your image will stay in a height of 1080. It's a good idea to not stretch your images, so keep the resolution the same. CFG scale is something that doesn't matter here because we did not write any prompts to the image because we want to keep our image almost the same, so this can be ignored. Denoising strength, on the other hand, can't be ignored. The lower the value, the more information Stable Diffusion takes out of the original image, and we want Stable Diffusion to take all the information out of the original image. So if you want some variation and some AI free will, you might want to turn up denoising strength. Seed, if you keep it at -1, it will always switch up with a random seed. We don't want that. If we want to apply Controlnet to videos, we need image sequences, and we don't want the seed to be different on every image. So it's better to enter a random number by yourself. As said, press the arrow to activate or open your Controlnet. Upload your reference frame. Press enable to enable your Controlnet unit. I personally recommend turning on low revamp. Here are the control types. I highly suggest you take a look at them. If you're into image generation with Stable Diffusion, you can limit the workings of A5 with it, like taking the depth map of a reference frame, take the pose of a person, and so on and so on. It's really great stuff. Unfortunately, color is not standing here. So preprocessor, we take a preprocessor that analyzes color. In my case, this is tile color fix. And as model, you need a color model. And in my case, this is T2I adapter color. You can always press the explosion emoji and test it. If you're doing this the first time on your machine, this might take some time because your machine will download the requirements. You can always open up the command line and see what's happening and what's downloading. If you think nothing is working in your interface, check the command line. I will also show you what happens if you do something wrong. In this case, we take any wrong model, press the emoji again. If a black frame or some noise comes out, something is probably not right and will not work. So always keep pressing the emoji and see what comes out. Variation is an interesting setting. It tells the Controlnet unit how much free will it has. So if we do an extreme and take this to 1, you will see that the Controlnet model will be very strict in where it places the color. Yeah, so this is variation free and you can clearly see where the mapping happens. Let's take this to another extreme and place it to 32. Yeah, and you see how it got really soft and how it applies things. I don't think that this is much wrong. The default value is 8. You might want to play around with it. So, we are working on AMVs, and the AMVs are videos. So how do we apply this to videos? First off, you generate an image sequence out of your AdSynth program, and you need to use the image sequence in the Stable Diffusion. For that, we go in the image to image tab, not to image, but to batch. And here we will input the directory where our image sequence lies, output directory where our finished images will go. We could also apply a black and white mask to every image. Maybe you find a good use to it. Personally, I can't think about any right now. So you go to the path of your image sequence, click right here and copy the path to the directory, paste it here. Then you paste the directory of your outcomes. And then if you press generate, Stable Diffusion will run the Controlnet and your commands on every image in your directory and render the final ready images to your output directory. Then you go back to your video editing software, import the new image sequence, and you're good to go. In my experience, an image sequence of about 1 second can take about 15 to 20 minutes to process in full HD. So let's move on to advanced techniques. If you have problems with your image sequences and your batch processing, you can still use color transformation on video. All you need to do is download EbSynth. It's a free AI software that applies a certain style of one image onto a video. And with this method, you only render one reference frame with your applied colors. Then you open up EbSynth. You go to keyframes, select your one single reference frame, then you select the image sequence of your video, then you tell the program the position of your keyframe in the image sequence. In my case, this would be 1. This is the position of your reference frame. You can decide if it's in the middle of your animation or at the beginning. In my case, I used the very first image of this image sequence, so it's the first frame. Then you can set the synth detail, then on how to use the GPU, yes or no. I would recommend that you use a GPU, so it might be much faster, and there are some advanced settings as well. And if you're done with setting up, you apply synth. To make this work, your keyframe and your images need to be the same resolution. But mind you that the EbSynth method works differently, and you might get some weird AI artifacts. Personally, I think it works on still images with less fast movements of objects or even camera movements. Just try it, maybe you get some interesting glitches with it. My next tip is about Controlnet. Did you know that you can stack multiple Controlnet units? So you might take one control unit that's all about color, the second one is about depth, and the third one is about a pose, and so on and so forth. This gets really render intensive in times, but at least if you're rendering images, I think this is a good way to control the wild Stable Diffusion AI as much as possible. Also, you don't need to process single images onto an image or an image sequence. You can also apply a batch. So your overlaid images can be an animated image sequence as well. So you might wondering, why would you do that? So here are 2 use cases. First off, I had this original scene from the movie Bubble, and in the middle there's a crossfade. The scene after the crossfade is actually too slow to be part of the video. It wouldn't time well, so I had to keep the crossfade. The final rendering looks like this. So what I did to make this work is I placed in my timeline the overlaid colors of the starting clip, which you can see here as an image sequence. Then I applied a crossfade to the next overlay. So I made my own color animation. I exported this as image sequence as well, went to my Stable Diffusion, entered patch, and as input directory I pasted the path of the new animated color image sequence. I also made sure that the number of input frames of my image sequence of the footage is the same as the number of the images in the image sequence of my color overlay. So these 2 numbers should match. You could also apply a Controlnet unit batch onto a single image. If you press process, Stable Diffusion would apply every image of the Controlnet image sequence on the image, so you would get an animation of a still image with an animated color unit on top. So the next tip I have for you is about preservation of original color. You might not want a color overlay affect your whole image. You might want to keep some of the original colors. In this case, I wanted to keep the natural tones of my character in this scene. For this to happen, I had to mask the character. Then applied an overlay, and I have the original masked out character on top of it. I blurred the whole image so things will go more smoothly in Controlnet. When I was done, I just composed all the images together. I had my raw layer as reference, I have my Controlnet processed batch, and I applied some variations of the mask character on it with some various blending modes and opacity settings to make things look right and dreamy. The downside is that you get some haloing around the character. So if you watch Onirika closely, you will notice that there are some haloing going around. What I do like about this method is that you get some quite natural, dreamy look with it, but it's not an accurate look. So if you want an accurate look, you might want to play around with the blurring of your mask or the Controlnet settings or even the colors you want to apply. Yeah, and for this scene, I took this background layer for colors, then I applied the face to it to keep some of the natural look, and I blurred it again to make it more fluent. And afterwards, I just composed it together. Here is the result I got from Controlnet, then applied the face to it and applied it again. And then I added a lens flare and some noise to the end to mix it together well. So about this scene, this was quite some work. First off, you need to do your rotoscoping and your masking. Then you need to bring your color overlay into place. The tricky part is that you have to track your color overlay to the moving background. On one hand, this was easier to accomplish because I had lots of stars to track. On the other hand, I think the background in these scenes are globes, so my tracking was not accurate at some points and I had to do them myself manually. I think there are some parts of this scene where you can see the flaws, but since you look at characters, you don't notice them too much, and I think it's enough as it is. And here is the same principle with the boy. So, alright, this is all I know so far on how to use Controlnet Colour Transformation for AMVs. I hope you learned something. I hope you can use a lot. Again, if you have any questions, just drop a comment and I will try to help. And I hope you can build on this knowledge and make something great and even better. See you next time.